is our science project. Now, let's introduce ourselves. Hi, I'm Cassie.
Hey, I'm Caitlin.
Hey, I'm Audrey. And I'm Jordan. This is our fabulous air mass poster.
Yay!
And an air mass is an extremely large body of air whose properties of temperature and humidity at any given altitude are fairly similar in any horizontal direction.
And now the definition of a source region. A source region is a geographic area where an air mass originates.
And now, we'll talk about all the air masses.
For the first air mass we're going to talk about, it's going to be the maritime. See here, the maritime tends to form over the oceans and combines with other air masses.
A maritime air mass originates over a large body of water. It's very moist and is also known as oceanic air mass.
Next we'll talk about the maritime polar air mass. The maritime polar air mass is cool and moist. It originates over the northern Pacific and northwestern Atlantic. It usually brings precipitation and clouds with it as it moves inland. Up next would be the continental polar. It is the big blue one in the middle, the lighter blue, not the darker blue. It's cold and dry.
Continental polar air masses are between 40 and 60 degree latitudes. They have very little moisture, and they are called polar latitudes not because they are near the poles, but because they are cold and dry like polar areas.
For our next air mass, we will be doing the continental tropical, which comes from the south. It's hot and dry.
Continental tropical air masses are hot and dry with stable air lofts and unstable surface air. They have warm to cool summers and cold winters.
Next up is the maritime tropical. They're the orange ones at the bottom. They come from the south and they're warm and moist.
The maritime tropical air mass is typically found in the southeast part of the United States. It originates in the subtropical part of the Pacific Ocean, but sometimes it originates over the Gulf of Mexico and the Caribbean Sea.
Now we'll talk about the tropical air masses. They originate in the south and tend to combine with other air masses.
A tropical latitude air mass surrounds the equator. It's warm to hot and is moist all year round.
The final air mass we're going to be doing is the continental arc, the very dark blue one towards the top. It's very cold and very dry.
The continental Arctic air mass has extremely cold temperatures. It forms over northern Canada and Alaska as a result of radiational cooling.
Now you're probably wondering what radiational cooling is, so let me tell you. Radiational cooling is the loss of heat from the Earth's surface, occurring mainly at night.
Hey! Okay, so you're probably wondering why we haven't just continued with the video. That's because we sent Jordan to the store to get Audrey some Mountain Dew.
She had a craving.
Yeah. So, as I said, we sent Jordan off to the store, and she'll be back in a couple minutes. We'll see you in a few.
Why are you wearing a coat? Because it's cold outside.
But we're inside.
I have a feeling there's a cold front coming on.
A cold front? Well, what's a cold front?
Well, a cold front is the leading edge of an anti-cold air mass. The temperature and humidity decrease, pressure increases, the wind shifts, and precipitation follows.
Oh.
We've talked about cold front.
Are there any fronts?
Well, yes, there are. Stationary fronts are fronts that stop moving, and temperature and wind direction changes happen within the front.
But aren't there supposed to be more fronts?
Oh, I remember. A warm front is the boundary of an advancing mass of warm air and the leading of the warm sector of a low pressure system.
Well, that's a lot of fronts, but isn't there one more?
Yeah, I think I remember now. It's called the occluded front. I remember. In it, thunderstorms are possible, and it's formed during the process of cyclogenesis when the cold front overtakes the warm front.
So what are we gonna do next?
Why don't we do a demonstration?
Okay. So what we're gonna do now is explain our demonstration. What we're gonna do is see what happens when a warm front and a cold front collide.
Cold front!
So now we're going to tell you what materials we are going to be using in our demonstration.
So what we're gonna use to hold all of it is this lovely container here.
One of the other materials we are going to use is canola oil. Another thing we are going to be using is lo and behold, water!
Hey!
And the last thing we'll be using is a little cardboard piece to keep them all divided from each other. In our demonstration, the canola oil represented the warm front and the water represented the cold front.
So you're probably wondering what that meant. Basically, the warm front rose to the top because it is less dense than the cold front that's sunk to the bottom.
Well, that's the end of our science project. We're sorry to say that Jordan isn't here to see it because, well, we sent her out to get more Mountain Dew. Didn't we, Audrey?
Yeah.
No, actually we didn't. Jordan had something else she needed to do, so she had to leave. But, hey, it was fun. The end.
But wait, there's more.
Okay. Hey, so we're gonna have a slight delay in recording the rest of the video because Audrey insisted upon getting more Mountain Dew.
She craves it.
Yeah, she craves it like I crave Funyuns.
The maritime
But aren't there any other fronts?
Oh, I remember. A worm front is. I'm sorry.
Divide the tank into two so we can have.
And this is our poster for air masses.
Yay.
An air mass is an extremely large body of air whose properties of temperature and humidity at any given altitude are similar.
And that's the end. For real this time.